Welcome back to Arcade. I am Super Tommy, and this is a series or a set of videos where we're going to make Pac-Man ghosts and the specific AIs for each ghost. Now, in the last video, we created this ghost you see here. We set up the ghost class and the basic movement logic for ghosts. So in this video, we're going to actually implement a state pattern for switching out different ghost AI behaviors into our core ghost class. So we have this scatter movement logic, and just to go over, scatter in Pac-Man is when each of the ghosts, Blinky here, the red ghost, Pinky, Inky, and Clyde, pick a different corner and they all scatter to that corner. So right now this is scattering to Clyde's corner, the bottom left of the Pac-Man board. And so right now he's just going to circle around this flipped upside down T forever until we give it a different AI behavior to do. So what we're going to do is abstract out this code that we made in the last video, which is right here. So some of this is core to the ghost class. So all ghost movement will need to choose when to move. And so the ghosts move when they get to a tile, like when they've moved completely over to a new tile, which we figure out here, roughly these lines here. And then if this is true, then we pick a direction, and that direction picking happens here. And then once given a direction, we move based on that direction. So you see there's basically three discrete parts in this logic, and one of those parts, well, two of those parts is common to all movement, and one of those parts is different. So specifically the different part is the picking which direction to go in. And so we're going to use the state pattern for this. So let's see if we can go over here, state pattern. So what is the state pattern? And Google's not so built well for this. Okay, Wikipedia is better. So state pattern basically lets you change the state that it's using at runtime. So in this case, for the ghost at least, the ghost can be in the scatter state, the chase state, or the frightened state. And so you would, in Pac-Man, it does this, where it starts off in scatter, I want to say. Then it goes to chase, and then when Pac-Man eats a pellet, a power pellet, they go to frightened state. And so you can switch that out or at runtime depending on what's happening in your game. Now this is similar to the strategy pattern, like Wikipedia says here. State pattern can be interpreted as a strategy pattern, and you can Google this and you'll see that you'd be hard pressed to find a good explanation of the difference between the two. And I'm not sure it really matters, but we're going to use a state pattern here. We're not doing a finite state machine, which uses states in its implementation. We're going to do a very simple state pattern implementation here, just really to use a different Pac-Man Ghost AI for each of the ghosts. So let's get started. Now we in our first video you saw that we demoed all the ghosts, so we have implemented this already. We're going to do it again. And so we're going to make a new folder here, new Ghost AI, to complement our new Ghost class. So let's do scatter. Since we already have it, we're going to just take our scatter code and encapsulate them in its own class that we can then pass in a state class that we can pass into our ghost, new ghost class here, new ghost. You'll see there's this set AI method that we don't do anything in other than return this. And once we have a specific state, a behavior, AI behavior that we're going to use that instead of this hard-coded logic in here. So let's go up here. We're going to make a new file called scatter AI in our new Ghost AI folder. I think we may not even need phasers, so let's just export default scatter AI. Yeah. Oh, because I didn't do class. Right. No, we don't need to use that. And you can see here in new ghost that we're taking in a ghost AI. So we briefly talked about this in the first video where we're programming against an interface and not an implementation. So one reason why we want to do this, at least in this case, you can see we can give it any AI behavior. So it could be scatter, chase, we have flank, intercept, and playfully chase, which is Clyde's behavior. So it could be any of those types. You can make up your own. You don't have to, if you're making your own Pac-Man. I mean, Pac-Man has the 4 AIs that it uses, but you can make up your own crazy AI however you want to do it and still be able to pass it in here without having to constantly update your code here to say, okay, take chase AI, take intercept AI, take flank AI, etc. We can just take the interface, ghost AI, and then all our various AI states and behaviors will implement this interface, and then everything will work. So that's coding against interface, not a implementation. Okay, back to our scatter AI. We want to implement the ghost AI interface, and VS Code imports it for us. Great. So now we're missing some methods. Of course, go here. We need these things and pick direction. So it's very simple. It's got a speed, it's got a target position, and then it's got a pick direction method. So let's implement this stuff. Get. So speed is a number. We're going to say everyone moves at 100, or at least in scatter moves at 100. And then target position, same deal. It's going to return. So at least for now, let's just do this. We will update this based on the actual target we're picking for the AI, implementation. And then pick direction. So let's just get rid of these errors. We're going to say direction none. So this is like the basicest, most basic implementation of the ghost AI interface, but it does nothing. So what we're going to do is now take let's just close all these close others. We're going to take our code here in the new ghost class that we did in the last video. Down here in pre-update, so we went over already, this is when it decides that it should pick a direction, right? All this code here. And then this code, up until here, is the actual direction picking. So this is what we actually want. So let's just copy that. And then move it into pick direction. Now there will be many things that are red squiggly. So we need the board. We need to know what the board is to know that the ghost can't actually go up here and go down here. And these helper methods that we have for getting the opposite backwards direction, let's just copy those imports. It'll probably, let me just re-import it ourselves because I think the path will be wrong. So let's see, import ghost AI utils. This is where the get opposite direction. Yes, get opposite direction. No. Find module. So where are we? New ghost AI. Up one. Ghost AI. Slash utils. Right. Slash. Oh, this is position in direction. Position in direction, and then for get opposite direction is over here, and then get ordered directions is over here. Now, if you don't remember what these do check out the first video, the previous video here. To we went over what these functions actually do. And then this is current direction. We can get that from the ghost itself, so that's fine. Okay, so now let's fix the rest of these squigglies. The GXGY, okay. Position in direction, okay. So some of this we can actually move back to the ghost class, but let's just do this first. So let's add a constructor. So we're going to want, at least for sure, we want the board. So that is phaser.tilemaps.dynamic tile layer. And then we're going to want the actual ghost that this belongs to. Let's put that first. So ghost, which is new ghost. Okay, we can actually do iGhost, right? Just so that we're performing against more interfaces instead of implementations. Like new ghost is a concrete implementation of iGhost. And let's see here. Let's store this ghost reference, and we're going to store this board reference, phaser.tilemaps.dynamicTileLayer. Okay, so this .ghost, ghost, this .board, board. So that's good. So this current direction we can get from the ghost itself. Okay. So now what we don't have is this gx, gy. We could recalculate it here, which is not a problem. So let's just do that. It's a relatively light calculation. So let's just do that to appease the VS Code error gods. Okay. Direction, best direction. Great. So we need to return best direction. All right. So now everyone is happy. Nope, it's not. We missed something. Where's my error? Oh, here, XY. Yes. XY, which was this .ghost.body .body. Oops. Body. Yes, because it doesn't have one. That's okay. We know that our ghost actually does have one. So let's just make that. Let's do a read-only physics body so that we don't mess with phasers. What phaser already does. That body. It will be a dynamic body. That means we got to go back to our new ghost. Right, you see these reds because we did not do this. So current get physics body. I'm going to return this .body as, so there's that squiggly because this could be either a static or a dynamic body. But we know it's a dynamic body. Okay, so back here, physics body dot position dot x dot y. Okay, cool. Now the scatter, well, just one thing at a time. This target position, so let's just go private target position, and we're just gonna, we could use a phaser point as well, but we'll just use this object. We don't do any actual, we don't have to call any functions on this, any methods on our object. So now we can return this dot target position, and here's txty. What we can do, well, we'll just do this for now, but we're going to change this shortly because we should be getting the target from the constructor. So when we create our scatter, where should it scatter to, or have a setter? Either one of those will work, but that errors are gone now. Great. So now let's go back to game. And so this ghost, we're going to do ghost.setAI, right? And then new scatter AI. So, but we're going to use the scatter AI that we are creating now. So let's just comment this, right? Then it will error here, which is okay. We're just going to comment that. And now let's import the scatter AI that we just comment out these old import scatter AI, the one that we just made, new ghost AI. what we're seeing. Okay, game, new ghost AI, scatter AI. So this is the scatter AI that we just made, right here. We just did that. So we're going to use that scatter AI. So we wanted the ghost, so that's the ghost, and the border layer. Okay. So now we've given it to our new ghost class. But of course, our set AI does nothing. It still works. We didn't delete that other logic, but it does nothing. So we should save our AI behavior in a class property. So private AI behavior, and then it's going to be an I ghost AI. Okay, and then it could be null because we're not setting it in the constructor. We're setting it as in this setter. AI behavior gets AI. So remember we took this code. Let's just delete this. And then, so const best direction is going to be this dot AI behavior, but it may be null. So in our case, if it actually is null, let's just do nothing. If there's no board or there is no AI behavior, just don't do anything. So dot pick direction, and then speed will be dot speed. So the way we have it here with our iGhost AI interface, still works, is that we can give it different speeds, and at the right time it's going to do pick direction. So we'll show you that if we change this none, it should just not move, right? No moving, no direction, doesn't matter what the speed is. So it is in fact using the pick direction method that we created. So let's just go back here. Right? So it's working. So now we can swap in whatever AI state behavior we want, and it will do it. So in this case, it's scattered specifically to the bottom left. So let's do this. We were already saying here, scattered AI. So we want to actually, in the constructor, say what the scatter is. So this is just going to be the target, basically. And then, so this dot target position dot x is going to be the past in x, and this dot target position y is going to be the past in y. And then instead of this, I'm going to do this. So this is maybe something new that you've not seen before, but this is object destructuring with a little renaming of the variable. So we're going to call it x. So we're taking x out of target position and calling it tx. We're going to take y out of target position and call it ty. So we have to do that because we already have xy here. So just to demo this for you in a silly way, A, B. And let's say A is 500, B is 600. What this does, so like this is basically target position, the X, Y changes A and B. A is going to be a constant, a variable A, that's equal to 500, and B is going to be a constant variable B equal to 600. So that's object destructuring in modern JavaScript and TypeScript. That's what this is doing, basically this, but this syntax lets us say create a variable tx that is set to the value of x in target position, and set a variable ty that is set to the value of y in target position, just like this up here. So that's object destructuring if you want to go look it up and read some more about it, but that's how you use it. Okay, so that's target position. We destructure out into tx, ty so that everything still works. Good. And that returns a target position. Great. So when it starts here, well, there is an error in game, but I think it's also gonna, yeah. All right, yes. So we need to specify. So let's say in this ghost, we're gonna go to the top left corner, which is, I think, Blinky's position. So here it goes. So there we go. That's a scatter. We can give it the position to scatter to. We can also scatter to somewhere completely different, and it'll just do it. And we'll just say x. What if I did x 512? No, x0, y 512. I don't even know where that is. Let's just see what this guy does. Yeah, it's gonna, let's just see. I don't know where that target is. It's probably somewhere over here, maybe? Over here. That's my guess. Well, anyway, this is the scatter logic. Just set this back to 0. And so now we're about 20 minutes in this video, which is shorter than the last one, but we implemented the basics of a state pattern. And we've got the scatter AI. This is the normal Pac-Man scatter AI, just picking which position to scatter to. Now in the next video, we're going to actually make Blinky's AI, and depending on how long that goes, we will make Pinky's AI as well. So come back for that video coming up next.